Hi guys, so I decided to make a recording of your absolute age quiz so that you could do it at your own pace at home. I'm sorry if the scan is a little bit funky, but we are unexpectedly at home, so I had to scan it from my phone. I've included a bunch of really good notes on here that you might want to be able to view on your own, so if you could split screen yourself, that might be a good idea. So for the first question, it asks, due to radioactive decay, an igneous rock sample now contains 1/4 of the amount of potassium-40 that it originally contained. The age in years of this rock sample is approximately what? Okay, so first you definitely want to take a look at the radioactive decay data on the first page of your reference table and look at potassium-40 to kind of give you an idea of what that half-life equation looks like. But then also keep in mind, you have to figure out how many half-lives have passed at this point. You have 1/4 of the amount of potassium-40 that it originally contained. So how many half-lives have passed at this point? I put a little chart on here that you can use if you want to, in order to give you a better idea. Okay, so pause if you ever need a little bit more time. So number 2 says the accompanying diagram represents the present number of decayed and undecayed atoms in a sample that was originally 100% radioactive material. So the dark ones are the undecayed atoms, are the ones that are left over, and the light ones are the ones that were decayed and they're no longer there. They're, decayed away. So it says, if the half-life of the radioactive material is 1,000 years, what is the age of the sample represented by this diagram? Okay, so we need to figure out, first of all, how many half-lives have passed. Okay, I did the counting for you. 8 out of the 32 squares are undecayed. They're left over. That's about 1/4 left. Okay, so if we know that the half-life of this material is 1,000 years, there's about 1/4 left. How many half-lives has it gone through? And then you would take that 1,000 years and multiply it by the number of half-lives, and you get the age of that sample. So what's the age of this sample? Okay, number 3. It says, base your answers to the following questions on the graph below and your knowledge of earth science. The graph shows the percentages of the radioactive isotope carbon-14 and its disintegration product produced during 4 half-lives of radioactive decay. So which disintegration product is represented on the graph? So make sure you're looking at your reference table. We know that this is carbon-14. Tell me what the disintegration product is that would be pictured on the graph that would go along with carbon-14. Okay, number 4 asks, how many half-lives have passed if a sample contains 25% of its original carbon-14? And I've included a little chart here for you. Okay, so is it 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives? How many half-lives have passed if 25% is remaining? Number 5 says the age of which index fossil could be determined by using carbon-14. So you're definitely going to need to know the approximate age of these index fossils, looking at pages 8 and 9 in your reference table. And then you need to remember that carbon-14 can only be used to identify fossils that are about 75,000 to 1,000,000 years old. Any older than that, and it would decay too rapidly, there wouldn't be anything left. So which one of these would you be able to identify using carbon-14? Okay, number 6. It says, base your answer to the following question on the data table below. The table shows the percentage of original carbon-14 remaining in 3 different fossils. The approximate ages of the gastropod shell and the tree wood are shown in years. The age of the human bone has been left blank. During what geologic period did all three fossils form? So you're definitely going to need to look at pages 8 and 9 in your reference table. And you want to be able to find a time period in which you'd have a gastropod shell, you'd have tree wood, and you'd also have a human bone. We're dealing with humans. Humans are relatively new to the earth, so keep that in mind as you're looking at it. Okay. So what geologic period did all three fossils form? So for the next question, you're gonna base it on this graphic here. So it says base your following questions on the geologic cross-section and photograph below and on your knowledge of earth science. The cross-section represents the Palisades Sill in northern New York State and the surrounding bedrock. Potassium-40 analysis determined the sill to be approximately 200,000 years old. The photograph shows a mastodon tooth found in glacial sediments nearby. Carbon-14 analysis determined this tooth to be approximately 11,400 years old. Okay. So I just labeled these where it says, you know, potassium-40 determined this to be 200,000 years old, and this is 11,400 years old. And the question asks, potassium-40 is useful for radioactive dating of the Palisades Sill because the half-life of potassium-40, what? So why do we want to use potassium-40? Why do we want to use any of these radioactive isotopes? Okay, the half-life of potassium-40, A, decreased as the amounts of Ar-40 and Ca-40 in the sill increased. B, remained constant or the same during the entire radioactive decay process. C, increased as pressure from the overlying sedimentary rock increased. D, was shortened by the high temperature of the magma that formed the sill. Number 8. We have this geologic cross-section below showing a complex structure containing a granite intrusion. Granite intrusion right here. If the granite intrusion occurred 24 million years ago, what's the most probable ages of the schist and the shale? So remember, an intrusion is always younger than the rock it goes through. So it's going through the schist, so we know the granite is going to be younger. The granite is 24 million years old. Number 9 says the accompanying cross-section represents bedrock that has been changed by several geologic events. Which geologic event happened most recently? A, the tilting of rock A. B, the intrusion of rock B. C, the formation of the unconformity at D. Or D, erosion of rocks B and C. Number 10 says base your answers to the following questions on the graph below and your knowledge of earth science. The graph shows the number of radioactive isotope X atoms present as a sample of the isotope undergoes radioactive decay. Based on the graph, what's the approximate number of radioactive atoms in isotope X that are present when 8 hours of decay have occurred? I marked right here, though it's kind of hard to see. 8 hours. How many radioactive isotopes are present? So just reading this graph. Okay, so also based on this graph, the half-life of this radioactive isotope is what? So I looked at this and I said, okay, if there are 1,000 atoms present at 0 hours, how long until there are half that amount? Okay, half of these atoms to be left. How many years? Or sorry, hours. And then that would be the half-life. Number 12, the table below shows information about the radioactive decay of carbon-14. What's the amount of carbon-14 remaining after 28,500 years? Okay, so I included a little graph for you here. So you'd have to think about how many half-lives is that and what fraction would remain. Number 13, which radioactive element is used to determine the absolute age of late Pleistocene animal remains? So you need to look at the age of this epoch on page 8 and then decide which radioactive element would be used to determine this absolute age. Number 14, the table below shows the radioactive decay of carbon-14. Part of the table has been left blank, so this is similar to the one we saw above. After 22,800 years, approximately what percentage of the original carbon-14 remains? So you can see the percentages up there, and at each line 5,700 years has passed, so you could manage to fill in the rest of this table by just adding 7,000. And when we're talking about the percentages, you can see it's divided in half, divided in half, divided in half. Okay, so at what point would you have 22,800 on this side? What would that percentage look like over here? Number 15, a fossil formed 11,400 years ago. Which percentage of the original amount of carbon-14 remains in the fossil? So you might want to use this table up here. Okay, so it formed 11,400 years ago. What percentage remains? So for number 16, you want to base your answer to the following question on this table below and your knowledge of earth science. The table shows the disintegration products and half-lives of 5 commonly used radioactive isotopes. Which graph below represents the amount of potassium-40 and the amount of argon-40 and calcium-40 over 4 half-lives? So we know that the disintegration products of potassium-40 are argon-40 and calcium-40. Okay, so what shows the appropriate decay of potassium-40 and the increase of argon-40 and calcium-40? Think about what you've seen other ones look like. For number 17, you're going to base your answer to this question on the earth science reference tables and this cross-section. Cross-section shows the rock structure of a region of Earth's crust. Letters A through H are rock units. Lines J, and K are interfaces within the cross-section, and rock layers A, B, and C have not been overturned. It gives you a key down here. So it says, which event occurred before the formation of rock layer B? So it's the one up here. The weathering of rock A, the faulting of rocks along lines JJ, the intrusion of igneous rock layer H, or the formation of metamorphic rock above layer A. Which one occurred before the formation of B? For number 18, it says the diagram below represents a sample of rubidium-87. Which diagram represents the correct proportion of rubidium-87 to its decay product? I don't know what that is. 87SR after 2 half-lives. So after 2 half-lives, what percentage of rubidium-87 will be left, and which of these pictures represents that percentage? Okay, number 19. The graph below shows the decay of a radioactive material over time. So we see that happening here. How long does it take for this radioactive decay to go through 2 half-lives? We see where the first half-life is, right? How about 2 half-lives? What would that look like? Number 20 says the geologic cross-section below shows several rock units of Earth's crust. Some rock units are labeled A through E. Which 2 rock units formed from sediments deposited in horizontal layers? Is it A and B, B and C, C and D, D and E? Remember, horizontal goes left to right. So which sediments do we see going left to right? Deposited left to right. Number 21, you're going to base your answer to the following question on the data table below. The table shows a percentage of original carbon-14 remaining in 3 different fossils. The approximate ages of the gastropod shell and the tree wood are shown in years, and the age of the human bone has been left blank. What's the approximate age of a human bone fossil? So notice that it seems to be going up by 5,700 for each one. So what would that mean for the age of the human bone fossil? Number 22, the image below shows a spear point embedded in a mastodon's rib bone found near Seattle, Washington. Scientists infer that early North American humans hunted the mastodon. Carbon-14 dating of the rib indicates that 2.4 half-lives have passed since the mastodon was killed. Approximately how many years ago did the mastodon die? So remember, we know that 1 half-life is 5,700 years. And this is 2.4 half-lives have passed. So actually, ignore my note here a little bit. So 2.4 half-lives would be how many years? If 1 is 5,700, what would 2.4 half-lives be? Number 23, base your answer to the following questions on the geologic cross-section shown below. The most recently formed rock unit is at location what? So the most recent, the newest, the youngest. Number 24, how old is a bone that has 12.5% of the original amount of radioactive carbon-14 remaining? So, in order to get this, you want to take 5,700 and multiply it by the number of half-lives that have passed in order to get 12.5%. I want to look at one of the charts that we included up. You know, might want to scroll back and look at a chart. And then 25. Radioactive dating of fossils and rocks is possible because radioactive isotopes A are found in all fossils and rocks, B are easily collected and measured, C disintegrate into organic substances, or D disintegrate at a predictable rate.